Alright guys, so this video I'll be going through this possible question. So in these types of questions, they're basically asking you to solve the simultaneous equation using the matrix method, right? So the first thing that you have to know is they will give you the question just like a normal simultaneous equation. But there were two ways to solve a simultaneous equation, which was the elimination method and the substitution method. So now you'll learn another way to solve the system of simultaneous equations using the matrix method. Okay, so to start it off, make sure the form of the equation in the form ax plus by is equal to c, as we see in each of these equations, xy equal to c, axy is equal to c. So it's in the form. So the first thing we have to set it up in order to solve it simultaneously, right? So the setup is like this. One matrix is for the coefficients. And this matrix here is for xy. That really change. This is equal to the constants. So there's a setup here really and truly, right? So the first thing, so here, constants is basically this piece here. Things on the other side of the equal sign. Okay, so yeah, that's what just in the order it's already. So it would be 5 and 13, that is the constants. Alright, that really change. So your coefficients is literally the numbers before the letter. So it'll be 2, 3, -5, and well, 1 is understood here. So that'll be 2, 3, -5, and 1. Okay, and you set up done. Basically, you set up done already. So now we need to solve for x, right? So second step, we could label each matrix. So we can label this A, and we can label this piece here x, and is equal to b. So watch this. So now we have ax is equal to b. So you want to solve for x here. So any character is the a to get x by itself. So any character is the a, you'll get x is equal to a inverse by b. Okay, so that's really the equation you can boil down to solve for x. Okay, remember step 1 was the setup, which is to get the coefficient matrix xy is equal to the constants, and you can get from the system of equations to give you on top here, where the coefficients are just the numbers before the x and the y in that order, and then the constants are the constants on the other side of the equal sign, and then you label it, second thing you label it x, a is the coefficient, x as well xy, and b is the constant. So you'll obtain this equation here. And the fourth thing, you just solve for x like that, okay? So from this equation here, we have b already. So the only other thing that we do have is a inverse. All right, so let's go and find a inverse. So let's write down what a was. So a, that was equal to 2, 3, -5, and 1. All right, so if you remember the equation for inverse, so a inverse is equal to 1 over the determinant of a by the adjoint of a. So if you're going to go on the page, the determinant of a is equal to a b minus b c. So we have a 2 by 2, so this will be a, this will be b, this will be c, and this will be d here. So the first one is a by d, which in this case is 2, minus b by c, which is -5 by 3, so that'll be -15. So the negative and the negative here will give you a plus. So you'll get 2 plus 15. So that'll be 17. So that is the determinant here. Alright, and now we have to get the adjoint of A. So remember, for the adjoint, there's two steps. Just in the form ABCD already here. So there's just a manipulation. So the first one is interchange where you swap A and D. So wherever D was will be A, wherever A was will be D. So in this case, A will be 1 because that was D, and D will be 2. You just swap the positions. And you swap the signs of B and C. You're not swapping the positions for these. So since B is positive originally, when it swap will be negative. And since C was negative here, we'll swap to be positive 5 here. And that is the adjoint. So that's the two things we need to get the inverse. So now A inverse, that's equal to 1 over the determinant, which is 17, multiplied by the adjoint, which is 1, negative 3, 5, and 2. Okay, so we could simplify this inverse here. So we could get A inverse. So to simplify it is just like expanding brackets. It has multiplied this outside here by each term inside the matrix. And you kind of like expanding the matrix if you want to call it that. So 1 by 17 by 1 is 1 and 17. 1 by 17 and 3 is minus 3 and 17. 1 by 17 and 5 is 5 and 17. And 1 by 17 by 2 is 2 and 17. So that is the inverse right here. So now, if you remember, we now have A inverse. So to get X, we just need to multiply A inverse by B. So let's go do that. So we have X is equal to A inverse, which we just find, 1 and 17 minus 3 and 17, 5 and 17, 2 and 17. Multiply that by B, which was 5, 13. I say here I'm about to multiply it up to the rows by columns. So let's check to see if it's compatible first. So this here is a 2 by 2. And there's a 2 by 1. So since the inside numbers are the same, they are compatible. And it will result will give you a 2 by 1. So let's set it up. So give you a 2 by 1. So that's all like we learn. You set up a 2 by 1. So this is 2 rows and 1 column. So you expect something here and you expect something here. Okay, so let's go. So now remember it's rows by column. So we have this row here, and we have this row here. And then multiply the balance when you have one column here. Alright, and that's like I normally do in the video. This is 1, this is 2, this is 1, this is 2, this is 1, and this is 2. So you're multiplying each number by itself. So for from the first row, 1 by 1 says 1 and 17 by 5. So that'll be 5 and 17. And the second one by the second one should be minus 3 and 17 by 13. So that'll be minus 39 and 17. Yeah? So now it have no more columns to multiply by, so you go across to the second row and repeat the step. So 1 by 1. So 5 and 17 by 5 will be 25 and 17. And the second by the second, so 2 and 17 by 13, so that'll be plus 26 and 17. Alright, so now we could simplify this. So that will equal to 5 minus 39. So that will be negative 34 and 17. And 25 plus that will be 51 and 17. Alright, so now to get the answer, we have to remember that x X, remember X was the matrix X and Y. So the final part, you will end up with X, Y, that was equal to what we just find there. So minus 34 and minus 34 and 17 is minus 2. And then 51 and 17 is 3. So you could equate, so that's equating across, so therefore X is equal to minus 2 and Y is equal to 3. And that is the answer there. So that's a recap. The first thing you do when they give you this question, you make sure that in the form ax plus by is equal to C in both of them, the x's and the y's equal to the constants. Because that is important for the setup. So the first thing you obtain the setup, so one coefficient matrix, xy, which is your unknowns, equal to your constants. Alright, and remember you could obtain it from these parts on top here. The numbers in front of the x and y goes into a coefficient matrix in the order it's already. XY doesn't change because that is the matrix with the unknowns that you need to solve for, and equal to the constants, which is just the stuff, the C's, or the pass across the equal sign. Remember, it's in the form AX plus BY is equal to C. If it's not in that form, you need to get it in that form in order to use the, well, in simultaneous and who. It need to be in this form. Alright, so after you get in that form, you just use the equation AX is equal to B. After you label it, coefficient is A, the unknowns is X, constant is B. You obtain this equation, you solve for X. You'll obtain A inverse by B, so you'll notice you don't have A inverse. So you go solve for A inverse, 1 over the determinant by the adjoint. Once you get the inverse, you go back up, you multiply the A inverse by B to get X. And then remember, X was XY, so you already solve it, so you just equate. And you will get X and Y, okay? So that's past paper, how to do the matrix method using, yeah, so simultaneous using matrix. So good talk, be safe.